Hello. This time I'm going to explain the homework problems from Precalculus Pearson, section 5.3, which is about the exponential functions. There are 16 problems to go. So first one is problem number 11, multiple choice. Determine whether the given statement is true or false. The function fx is equal to e to the power of x is increasing and is 1-to-1. And this statement is actually true. This is an exponential function with the base is e. And base e is constant 2.718 which is greater than 1. So exponential function with a base greater than 1 looks like this. It is an increasing function and it passes a horizontal line test. So this is a 1-to-1 function as well. So the statement is false, 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 true. So this is only correct one. So statement is true because this one is an exponential function with base greater than 1, which means it is an increasing function and it is a 1-to-1 function. Okay, I want to go to next question. Okay, number 2. So suppose we have 5 to the power of x is equal to 5 to the power of x. What can we say? Well, because the exponential function is a 1-to-1 function, and 1-to-1 function indicate that if input is different, then the output is different. That's the definition of the 1-to-1 function. Taking a contrapositive statement of this, this can be also stated as if the output is equivalent. If the output is the same, then input must be identical. So because output of the exponential function 5 to the x is equal to the output when you put x is equal to 6, so the input x must be equal to 6. So you can say this way as well. So we can say x is equal to 6. Number 3. Which of the following exponential function is an increasing function? The exponential function is increasing like this way when the base is greater than 1. And the exponential function is decreasing when the base is between 0 and 1. So looking at the choices, all these are exponential function. The first one has a base greater than 1, while the others have a base less than 1, like 3/8, 0.2, 0.9. So this is the only exponential one with base greater than 1. Okay. Which of the following is a range of the exponential function fx is equal to a to the power of x, where a is greater than 0 and not equal to 1? So it's only say a is greater than 0 and not equal to 1. So there are two possible kind of graph. One is when base is greater than 1, and another one is when base is between 0 and 1. Yeah. However, regarding the range of the function, in either case, it is 0 through infinity and 0 is not included. So this is the correct one, the other is not. Exponential function always have a positive value for the output. Okay, this one is just like approximate each number using calculator. So you just type in into, for example, Desmos or GeoGebra or Wolfram, anything. On this one is again, just use a calculator. So I'm gonna skip this. Okay, determine number 7. Determine whether the function given by the table is linear, exponential, or neither. Okay, so if the table indicates a linear function, if increment is identical here, then the increment in y value is also the constant. So when x is increasing by 1 from -1 to 0, y is increased by 5. But in the next step, the increment is 10. So it's not a linear function. Is it the exponential function? If it is exponential function, then looking at the possibility, looking for the ratio. So from 5 to 10, it is doubling. 10 through 20, it's also doubling. So this might be exponential function. However, when we look at the next step, it's increasing from 20 to 30, which is not multiplied by 2, but something else. So this is not the perfect exponential function either. So the best choice here would be the function is neither linear nor exponential. Okay, now next one, by looking at these choices again, it is increasing by 6, increasing by 6, increasing by 6 and 6. So this is increasing at a constant pace. So this is a linear function. Linear function, when you look at the graph, when x is -1, y is -2. When x is 0, y is 4. When x is 1, y is 10. So the slope is 6. And the y-intercept is 4. So it's going to be y is equal to 6x plus 4. That's going to be the model of this function. Okay. Now, this one was a problem that originally G's were, this is a matching question. So I already wrote down the answer here. So the original program is not written here, but let's see. So 37 through 44 is just a matching question. All of them is like obtainable by doing some simple transformation to the graph of y is equal to 5 to the power of x. So 5 to the power of x looks like this. It goes through 0, 1 and 1, 5. And it has a horizontal asymptote at the x-axis. Okay, so first one, y is equal to 5 to the power of negative x is replacing x by negative x. So it's gonna flip everything with respect to y-axis. So the graph looks like this. Next choice, like 5 to the power of x minus 1, replacing x with x minus 1. So it's moving the entire graph horizontally by 1 unit. So it goes through 1, 1 instead of 0, 1. So the graph looks like this. Okay. Next choice, negative 5 to the power of negative x. The front negative sign here indicating there is a vertical reflection with respect to the x-axis. So you're reflecting this one with respect to x-axis. So the graph looks like this. Sorry, next one. Y is equal to 1 minus 5 to the power of x. So first of all, this is you have 5 to the power of x is multiplied by -1. So you flip it with respect to x-axis. Then you add 1. You add 1. So you want to have a horizontal asymptote y is equal to 1. And it looks like this. Looks like this. Okay. And yeah, I'm going to stop explaining this. Basically, the transformation rule is applied the same for parabola or exponential functions and so on. Yeah, so just apply those rules here. Okay, well, use the transformations to graph the function, determine the domain, range, horizontal asymptote, and y-intercept of the function. Y is equal to 7 to the power of x minus 1. Okay, so let's graph y is equal to 7 to the power of x minus 1. So this is an exponential function with base greater than 1. So basic idea is looks like this. Since this is translated horizontally by 1 unit, So let's draw from the point when x is 1. So when x is equal to 1, y is equal to 7 to the power of 0, which is 1. When x is 2, it's going to be 7. And when x is 0, y is 7 to the power of negative 1, which is 1 over 7, somewhere here, okay? And using the idea, the curve looks like this way. I'm going to draw like this. Okay, now I need to find the domain. Domain of the exponential function is all real numbers. Range would be all positive numbers, all positive numbers. And the horizontal asymptote is the x-axis or the line y is equal to 0. Y-intercept is, we already found it here. It's going to be the value of y when x is equal to 0, which is 1 over 7. Okay, number 11, slightly harder, but another exponential function. Fx is equal to minus 6 minus e to the minus 6 over 2. So there are more changes involved here. So let's start with e to the power of x. So e to the power of x is exponential function with base greater than 1. So graph looks like this. Now x is replaced by x over 2. So it's going to be horizontal stretch by factor of 2. So it's going to be like more like, it's not like this, it's more like you stretched horizontally by factor of 2. Then x is replaced by negative x, which means they're going to be horizontal reflection with respect to y-axis. So graph looks like this. Then everything is multiplied by negative 1. So they're going to be vertical reflection with respect to x-axis. So graph looks like this. Finally, you are adding negative 6 to everything. So it's going to be vertical translation by negative 6 unit. So the horizontal asymptote is sending down from y is equal to 0 to y is equal to negative 6. So the graph looks like this. Okay. So that's the idea. We can draw it a little bit faster. Basically, exponential function approaches 0 when this becomes negative, getting larger and larger in negative value. So this part will become 0 as x approaches infinity. And y value is going to be negative 6 plus this little number. So basically this negative 6, the horizontal, horizontal shift, vertical shift kind of tells you where the asymptote is. After that, since this is some kind of exponential function, just plug in a few points. For example, when x is 0, it's negative 7. And when x is 2, it's negative 6 minus 1 over e. Okay. And when x is negative 2, it's going to be negative 6 minus e, which is 2.7. So it's going to be somewhere around here. So the graph looks like this. Okay. So the, as long as you know where the asymptote is, just plug in several points. Well, 3 points. In this case, just plug in when x is negative 2, 0, 2 would help a lot. Okay, domain, all real number, range, negative infinity through negative 6. And what? Yeah, horizontal asymptote is y is equal to negative 6. Okay. Now, next one is just the equation. 2 to the power of x cubed is equal to 64 to the power of x. To solve the exponential equation, in general, we need the use of log. However, when we have a similar base, in this case, similar means both of them can be written as a power of x, power of 2. In such case, we might be able to solve it without the help of log. So first of all, 64 is same as 2 to the power of 6. So using an exponential rule, a to the power of x to the power of y is equivalent to a to the power of xy. So this is same thing as 6 to the power of 6, 2 to the power of 6x. Remember the exponential function 2 to the power of x is a 1-to-1 function. So if 2 to the power of x is equal to 2 to the power of y, that means x is equal to y. So x cubed must be equal to 6x. Solving this quadratic equation by factoring, you will get x is equal to 0 or plus minus square root of 6. Okay. Okay. Next one is also exponential equation with a similar base. Okay, so right-hand side is same thing as e to the power of 5x over e to the 4th, which is same thing as e to the power of 5x minus 4. Using this kind of idea, we will get x squared is equal to 5x minus 4. This is a quadratic equation, so move everything to the right side of the equation, factor it, and you will get x is equal to 1 or 4. Number 14. Okay, let's say 3 to the power of x is equal to 4. What is 3 to the power of negative 2x? Okay, so we just need to connect this one with this. So using exponential rule, this is same thing as 3 to the power of x to the power of negative 2. Since 3 to the x is equal to 4, this is same thing as 4 to the negative 2, which is 1 over 16. Now, if you have learned the log, then you can find x as well. So 3 to the power of x is equal to 4 indicate x is equal to log of base 3 of 4. So plugging this number into this equation, this expression, it's going to be 3 to the power of negative 2 times log of base 3 of 4, which is same thing as 3 to the power of log of base 3 of 4 to the power of negative 2. And using the property of the inverse, this is equal to 4 to the negative 2, which is 1 over 16. So this can be solved by first find what x is as well. Okay, not much to explain. Look, determine the exponential function. So you start with exponential function form like some number times b to the power of x. This is a basic model of the exponential function. Since the two adjacent points here, when x increased by 1, when x is increased by 1 from 1 to 2, the y value is multiplied by 7, so you know the base should be 7. So fx is equal to 7 to the power of x times something. However, when x is equal to 1, y is 7, so times something, that something should be 1. So it's just 7 to the power of x. Simple one. Okay, last question. Find exponential function. So we want to find the exponential function with the horizontal asymptote -9. And it contains the points 0, -8, and 1, -2. Okay, so the graph looks like this. So let's write down the fx is equal to some number times base to the power of x minus 9. Let's shift everything 9 upward to think it clearly. So if we move everything 9 above, then the y-intercept is going to become 1, and 1, 2 become 1, and adding 9, so it's going to be 7. So this is like a basic exponential function with base 7, because when x is 1, y is 7. So this is same thing as 7 to the power of x, which is which sent down by 9 units. So this is gonna be the expression satisfying all the conditions given. Okay, so that's complete explanation for section 5.3, which is about exponential function. On the next one, we will I'm going to explain logarithmic function in section 5.4.